Bismillahirrahmanirrahim. This is June 2013 and it's variant 42, question number 7 in our past paper in worksheet question number 36. What a question is 0.26 mass of a particle. So if I make the diagram, so into 10, so this becomes 2.6 because 0.26 into 10, it point decimal shift, so it become 2.6. Okay, 2.6 Newton weight acting downwards. Okay, and what is this, students? It's a very clear approach. This is a 2.6 sine alpha. Okay, and let's read a further part. And it's saying that second mass of B particle is 0.52 into 10. I get 5.2 newtons. All right. Line number 2, the string passes over smooth pulley. In our whole syllabus, pulley remains smooth. Make sure no rough pulley in our syllabus, whole mechanics. And plane can be smooth or rough, but he's saying plane is smooth. So 100% friction is zero. And there's a common sense. We have a R upwards and his weight component downwards. Sorry, 2.6 cos alpha. No need to make it reason because when there's a friction is no friction is there. So don't make R component because we will not no need of R component. Okay, the plane is inclined and alpha is given here, cos alpha given. So I think we can use the formula values directly rather than finding some student take sine inverse, get alpha, then you plug in here. Why waste our time? So simple sine alpha because matching. So I can plug in 16 or 65 here. So and very clear. Okay, A is held at rest at 2.5 meters. You can see that is the distance is 2.5 meters. Held rest means starting velocity 0. Okay, and with the part AP mentioned clearly. And further, what is left behind? 0.6 meter height of the B from the ground. Okay, and further, what left? A released and moves downward. So that means starting velocity 0. Task number 1, acceleration. Task number 2, tension. So 5 mark. So I said there's a simple criteria whenever we're pulling a string. For example, one person pulling here and one person pulling here. So naturally tension towards each other and they are always equals to each other. So if I write this part of string below and this part of string here, so in this sense, it means I can say that tension will be equals to each other. These tension are the same like that. And towards pulley, make sure whenever pulley involve questions, so tension always towards pulley. Now, what is the next plan, students? So I think we can start the question easily now. First of all, I write equation for B particle. B particle. Because as he said, particle released, so it's moving. So this moving, naturally B will move this way. Okay, so motion is this way. And A particle will move this way. Okay, so have a look now. What is the B component? So weight component, what is the basic formula? Net force equals to MA. Okay, so net force equals to MA. I will use this connection here and have a look. What is the net force? Because coming downwards, because this bigger force, so 5.2 minus tension equals to MA. 5.2 minus tension equal to mass of the B particle is 0.52A. Equation 1 done. Now I'm going to make same situation for the particle A. Particle A, because motion is upward, so it means tension is bigger, weight component is smaller. I'm writing here tension minus. Okay, before I write the values, okay, students. So what was here? Because we know that sine alpha value is this. I am going to plug in here. So 2.6 time to 16 over 65 because the sine alpha value. So 16 over 65. And if I type this in calculator, 2.6 into 16 over 65, it is giving me 0.64. So I am writing this as a 0.64 because system is going upward. So this bigger, this smaller. So I can say tension minus 0.64 equals to MA. And what is the mass of the A particle? 0.26. Now, students, I'm going to solve them simultaneously. Okay, first of all, this equation I am copying and I'm pasting here. And then I'm doing this equation, copy and paste. Okay, and now students, what I will do, I will just solve them simultaneously. This tension cancel out, and from 5.2 subtract 0.64, I get what? 4.56, and here I get 0.78, and when I this will divide under it, I will get divide by 0.78, and answer I'm getting, and so here. So acceleration is clear, and I'm getting here 5 acceleration is 5.84615. And after rounding, I'm writing it to what here, students? Acceleration is 5.85 meter per second square. So I believe this is part is very clear. We got acceleration, but he said no, give me tension also for 5 marks. So this value I can plug in any one, but I'm plugging it here. Number two. So put in 2. So tension minus 0.64 is equal to 0.26 times 2 is 5.85. And just solve typing in calculator. So into 0.26 and plus 0.64. And my answer is coming finally, if you check it, it is coming 0.66. Wait a minute, let me check again. I think I should add here. I did mistake. 0.26 times to 5.85 and 0.46 add. And my answer is coming finally 2.16 newtons. So Alhamdulillah Rabbil Alameen. First part is completely over. So let's go for the part number 1 is done. Part number 2. Part number 2 is a little tricky because part number 2 he mentions here that the speed of B we have to find just before the reaching the floor. This part is not harder. B, okay. So because starting from rest, so what is distance 0.6 it has to travel? So I'm writing title here for B. Starting velocity 0 and acceleration I will use same. So I'm using acceleration 5.85 and distance to travel is 0.6 meters. Have a look, please. 0.6 meters. So B will reach the ground. So what is velocity just before hitting? So that is our target. So 2as is equal to v squared minus u squared. 2 times 2, 5.85. And s is 0.6. Last velocity is the target. And u is a 0. So when I take a root, velocity is coming finally. I'm writing here 2 times to 5.85 and 5.85 into 0.6 and take a root of this. So this is turned to be 2.6495. And after rounding, I get a 2.65 meter per second. Now here, important part going to start. Here students, what is the important part? Just show you. He's saying that find the distance of A from P. Okay, A from P when A comes to rest. So now it is a very important thing I'm going to discuss. Let me erase all these things, then I discuss. So listen, please. We know when you talk about B particle, B will travel downward here. Naturally, A will move up here. And what is distance travel here? Same distance travel here. So this is 0.6, this is also 0.6. So one point is very clear. Number one. Okay. And number one, what is speed here? 0. What is speed here? 0. Okay. What is speed here? Let's say 1. What is speed here? 1. I mean to say they are traveling with the same speed, both particles. So what just before hitting the ground? That particle speed is 2.65. So it means just before hitting the ground, the speed is here 2.65. What is speed here? 2.65. So I'm writing here speed is 2.65. Okay, but it will not stop. B will stop here. A will not stop. A will go slightly up, and then it will stop here. And this motion is called motion due to inertia. Like I give example. When a person is pushing a car, let's say this man pushing a car. So where the car is moving, right? When this man stop pushing the car, what happened? Do you think it stops same time? No, it will move slightly forward and then stop. And that is motion is called due to potential or due to inertia. Same words. And very interesting. This is a separate motion. This is a separate motion. But very interesting. The first situation, the motion, the final velocity is 2.65, and the inertia motion second stage, the starting velocity is also same 2.65. So it means ending velocity of this, starting velocity of this, they are equals to each other. Now I'm giving title particle A, motion due to inertia. So I'm writing here for A, due to inertia, due to inertia. Okay, and I can say that starting speed is same 2.65. Okay, now interesting part, what I have to find distance actually, small distance traveled here. I don't know how much. Ultimately stop on the peak, so I can say that at velocity ultimately 0. So thing is that, can I find S? No, I can't find S until unless I have acceleration. For your knowledge, as this particle hit the ground, so acceleration will no more same. It means this acceleration same, but after hitting the ground, B will hit the ground. At this moment, this moment of inertia, acceleration will change. But how to find that? So let's show the diagram again for you. This is diagram, and students, tension upwards and weight component downwards, and weight component is same, students. What is this? You know it very well. This is a 2.6 sine alpha, and I found it before. If I plug in 16 by here, so this weight component is how much? 1.9, I think, but let me confirm again. 16 over 65. Yes, it is a, wait a minute, 2.6 into 16 or 65 is giving 0.64. So this component is actually 0.64. 0.64. It means weight acting downward, 0.64. Okay, so what is the basic formula? Because system is going upward, so motion upward, so net force equals to MA. So tension minus 0.64 equal to MA. And what is the mass of the particle A? That is a 0.26. So 0.26 A. But student, tension equal to 0, you ask reason. Why reason? Because look at, come back on diagram. When this particle hit the ground, so tension in a string, as you know, both tension are equal until they hit. So as this particle hit the ground, B particle, so what happens, students? This tension becomes 0 automatically, because nothing, the stress is no more in the string. So I can find an acceleration from here. It will go down under 6.64. And if I divide it, I get acceleration negative 2.46. 462. Now I got, Alhamdulillah Rabbil Alameen. I can use this 2as is equals to v square minus u square. 2 times 2 negative 2.6, 462, sorry, 462. And s is target, last velocity, 0, and u is 2.65 power 2. And ultimately, when I check it, what answers turn to be? Let me check into 2, and 2.65 square divided by answer, and my this is coming 1.426. Let me recheck again as I'm typing correct or not. 1.2426, correct. Okay, this distance I got it, students. So now, interesting part. What is the question he is asking actually? It means if I rub the diagram and I show you, this is a, wait a minute. Yeah, I think I show you, I erase it. I erase it. Because student, this is total distance is what? 2.5 meters. Okay, it is moving how much equal to that? So 0.6 meters. and this distance I just got it what, 1.426. So if I add them, okay, 1.426 plus 0.6, it is giving us the distance traveled is very, very clear. I'm writing it now, that one. So distance traveled is how much? Is a 2.026. Okay. And but thing is that what a question he's asking. He's asking find the distance of A from P. Okay. It means A from P when it so A from P. It means this is my target. So look, this is my target. Okay, some student think that add them is my answer. No, student. From 2.5, we have to subtract this one. So I'm going to write here. So distance from AP. So distance AP. Distance AP. So what distance AP, students? So 0.6 plus 1.426. What I got answer. So this answer, sorry, I have to subtract from that is the first distance 2.5. I repeat again what I'm saying. What I'm saying, answer becoming 0.4. Well, let me check. 2.5 minus 0.6 and minus 1.426. And answer is coming finally 0.474 meters. I just revise again what he's asking for. He's not asking this distance travel, no, sorry. He's asking how much distance from the P to A, like how much a distance of A from P. So that is why from 2.5 we have to subtract 0.6 and this, and that is why you can see that I subtracted and I got my answer. Alhamdulillah Rabbil Alamin.